private key. Since I have my private key stored as an environment variable, I need to then run source .env so that my private key is now updated. The reason we're using this is because, again, since we're making transactions to a testnet, we need some testnet ETH. All right, so now we have everything updated for deploying to Rinkeby. Let's go ahead and run this now. As you can see, it's going a lot slower. This is because we actually have to wait for the contracts to get mined and for everything to happen on the testnet. Deploying to a testnet will result in nearly the exact same experience that you'll get when deploying to an actual mainnet. So it'll take a lot longer, but you can see we got the exact same responses here. Now, if we take this address and we go to the Rinkeby Etherscan, we can verify what just happened. We can see that 38 seconds ago, we made this transaction, and then 23 seconds ago, we made this transaction. We can look at all the different details of this transaction that we just made from our Python script. We can see it even tells us we created a smart contract, and then we made this call, which called this store function on this contract. Whew, we've learned a lot so far. This is fantastic. Now is a perfect time to take a break and take a quick breather and reflect back on what we've just learned. We've learned a lot about Python, deploying to our own local blockchain, deploying to a testnet, and deploying to a mainnet, working more with private keys, creating transactions, signing transactions, and then sending transactions. Now, as you can see, there's going to be a lot to actually managing all the contracts that we work with. Having to write our own compile code, our own storage code is going to take a lot of work. And what if we wanted to interact with one of the contracts that we deployed in the past? Well, we'd have to keep track of all those addresses and manually update our address features here with an address. Maybe we didn't want to deploy a new contract every single time. Maybe we wanted to work with a contract that we've already deployed. What if we want to work with a whole bunch of different chains? What if we want to work with Rinkeby and mainnet and our own local network? There seems to be a lot to manage here, and we still haven't even talked about writing tests. This is where Brownie is going to come into play. Brownie is currently the most popular smart contract development platform built based on Python. It's used by DeFi giants like Yearn.finance, Curve.fi, and BadgerDAO, each having billions of dollars currently locked in value. And the reason that we learned a little bit about Web3.py first is because Brownie heavily relies on Web3.py. So let's do all this again, but in Brownie, and we'll see how much easier it is to actually interact with. In our shell, let's go back one directory and let's make a new one. We'll call it Brownie Simple Storage. Now, another really cool trick that VS Code has is instead of us having to go to File and open up this folder in this Explorer here, what we can do is we can type code and then type the directory that we want to work with. In our case, this directory. So we can just type code dot. And we'll get a new VS Code pop-up inside of this Brownie Simple Storage folder. Let's get learning about Brownie, and this is where you're going to spend the majority of your time moving forward. Brownie is incredibly powerful and makes our lives fantastically easier. So get ready to learn one of the most powerful tools in the smart contract developing ecosystem. Let's go ahead and open up our terminal, and let's get started installing Brownie. It's recommended to install Brownie via pipex. Pipex installs Brownie into a virtual environment and makes it available directly from the command line. Once installed, you'll never have to activate a virtual environment prior to using Brownie, which is really good. To install it with pipex, we can go ahead and run python -m pip install --user pipex. Once we've run that, we can then run python 3-m pipex ensure path. Then we'll want to close the terminal by hitting the little trash can and then reopen it. And then we just need to run pipex install brownie. I've already got it installed, so that's why we see this here. And then just one more time, we're going to close and reopen the terminal. You can tell you have Brownie installed correctly if you run brownie --version. And you get some output that looks something like this. Or you just run straight up Brownie, and it'll output a bunch of commands that we can run. Let's create our first Brownie project. We're going to be using the exact same simple storage code that we just went through, except for we're going to use it in Brownie. This is going to make our lives a lot easier when working with simple storage. To create a sample folder with everything we need with Brownie, we can just run Brownie init. and we will get a new Brownie project initialized in the directory that we're currently in. If you type ls, you'll be able to see all the folders that are created, or you can just see them on your side panel in VS Code. Let's talk really quickly about what each of these folders is going to do. The build folder tracks a lot of really important low-level information. It's going to track any interfaces that we're working with or deploying. It's going to keep track of all of our deployments across all of the different chains, so we no longer have to manage that ourselves. And it's going to store all of the compiled code. Remember how in our simple storage code, we actually saved everything to this compiled code.json? Well, Brownie is actually going to do all of that for us into this contracts directory, so we can always reference it later. This contracts directory outside the build folder is where we're going to put all of our contracts. Brownie knows to look inside of this folder when looking for new contracts to compile, deploy, or anything else. Interfaces is where we can save and store different interfaces. Remember how when we were working with Chainlink, working with interfaces makes it really easy to interact with a blockchain application. Reports are to save any type of report you run. Scripts are we can automate tasks like deploying, calling different functions, or really anything we want. And then we have a tests folder, which is incredibly powerful and we're going to be using a lot. We also have git attributes and git ignore, which are helpful when working with version control like Git. So let's go ahead and start working with Brownie and really understand what's going on here. So let's go ahead and add our simple storage contracts to the contracts folder. So in here, we're just going to make a new file. We'll call it simple storage.sol. And I'm just going to copy and paste the code I have from the simple storage that we've been using this whole time. Let's go ahead and save that with Command S. Okay, great. Now that we have our contract in here, we can already start working with Brownie and even compile this code without even having to write or work with our own compiler. All we need to do is run Brownie compile. Brownie will automatically read the version of Solidity and then store all of the compile information in this build folder. So if we go to contracts, we can see we have a simple storage.json, and there's a lot of familiar pieces in here. For example, we see the ABI, opcode section, which is the low level language. We'll see a PC map and we'll see a lot of useful information. And great, obviously deployments and interfaces is still empty. So great, we've already compiled our smart contract. So how do we actually deploy this to a blockchain? To do this, we do have to write a script, which will allow us to do whatever we want. So we're gonna create a new file, and we're just gonna call this, similar to last time, deploy.py. This is where we're gonna define working with and deploying our code. Brownie can run scripts by running Brownie run. In fact, if you want to take a quick minute to familiarize yourself with all the different commands that Brownie has, just run Brownie and you'll see we can do a lot of different things. We can do Brownie init, which will create a new Brownie project. We will do Brownie bake, which allows us to pull from the Brownie mix, which we'll talk about later. We can compile, we can go into a console, test run, we can do a lot of wonderful things in here. If we do Brownie run, it'll run a script for us, and we can define that we want to run this deploy. All we have to do is add a def main. So def in Python is the way to define a function. We're going to call this function main. And for now, let's just say print hello, and we can run Brownie run scripts deploy. And as you can see, it automatically does this launching thing. So Brownie defaults to always working with a local Ganache CLI blockchain. It's running the exact same command that we ran earlier, and it has a bunch of different flags like accounts 10, a certain hard fork, a certain gas limit, etc. So at the beginning of all of our scripts, if we don't give Brownie a network to use, it'll spin up a local Ganache, and at the end of the script, it'll tear it back down. Typically, what I like to do is actually put all of the logic of our deployment in its own function. Def, deploy, simple storage, and we'll do pass for now. And then our main function, we can just call deploy simple storage. Now, in order to deploy our contract, let's look back at our Web3 Pi version of deploying this and see what we did. So first, we compiled it. Great, Brownie does that automatically. Then we dumped it to a file. Great, Brownie does that automatically. We got a bytecode and an ABI. Great, Brownie does that automatically. We added a local blockchain to use. Great, Brownie automatically spins up a local Ganache. We'll learn how to do testnets in a little bit. Aha, we do need an address though and a private key. So how do we actually get our private key, get our account into Brownie? Brownie has an accounts package that actually natively understands how to work with accounts, and we can import it into our script here. So we can do from Brownie import accounts. And with this accounts keyword, we can add an account a number of different ways. If we're going to work with our local chain, as you see here, the Ganache CLI will spin up 10 fake accounts for us. And Brownie automatically knows that we can work with that account. So we could do something like account equals account 0, and then just do something like print account. So we're going to take the account that's spun up at the 0th index, because this accounts object is just an array. So if we run this now, Brownie run scripts deploy, it's going to spin up us an address and a private key that we can just work with without having to define a private key or do anything. It does all of that for us, which is fantastic. We do, of course, still want to know how to add our own private keys so that we can work with a testnet. So this is great and works when we're working with a development network or working with Brownie's automatic Ganache CLI. If we want to work with a testnet though, we have to do something else. Another way to add your accounts in Brownie is to use the command line and actually add them natively into Brownie. We can do Brownie accounts new, and we'll give it a name, free code camp account. This will then prompt us and say, enter the private key that you wish to add. Let's go ahead and grab our private key from MetaMask, account details, export private key, put your password in, grab the private key, and then we just add OX and paste it in. Brownie will actually password encrypt your private key in this way. So we'll give it a password. And now we have a new account natively integrated into Brownie. To see it, we can do Brownie accounts list, and you'll see that we have a free code camp account with this address and also a testing account. I made this a little bit earlier. We can get rid of it by running Brownie accounts delete testing. Helpful terminal tip time. So if you hit up or down on your keyboard, you can actually toggle through the history of the commands that you've written. So if you hit up, it'll actually bring you to the most recently run command, which can allow you to run previous commands a little bit faster. And if we run Brownie accounts list again, we'll see it's now just free code camp. If we want to work with this free code camp account that we've added to Brownie via the command line, we can get it with account equals accounts.load free code camp account. And then we can do print account. Let's run this script again. This time when we run the script, it's going to ask us for the password. We need to enter the password to decrypt the account because right now it's password encrypted. So we're going to type in the password and it's going to go ahead and execute with our unlocked private key. We can see the address it printed out was right here. And if we copy the address and we go back, we can see that that is correct. Now, if we're going to talk about safety and you want to safely secure your keys, this is one of the safer ways to do it because it's not going to store it in Git. You're not going to accidentally push it up to GitHub or show it to anybody, and it's going to be password encrypted. This is going to be one of the ways that I highly recommend you store your keys. Oftentimes, you're going to want to do a mix of working with the local Ganache ones and your own keys, and we'll learn how to flip back and forth between them in a little bit. Now, the third way that I like to use is still, again, using an environment variable script. Oftentimes, it's really easy just to have your private key be an environment variable. This way, you won't have to keep putting the password in every single time you run a script. So it's a little bit less secure. And just another tip for myself, I never put my private keys associated with wallets that have real money in them as environment variables or in a .env file, just in case I accidentally do something really stupid. I don't trust myself enough. So I'm going to highly recommend that whatever private key that you use and you store as an environment variable here, always have it be just kind of a test account that you're going to use to test things. And then for some of your more serious accounts, that's what you'll use the encryption for. So let's go ahead and create an environment variable file. So we'll do a new file, call it .env, and we'll do export private key OX this. Now we have a private key set as an environment variable. So Brownie has an additional feature that allows us to easily work with environment variables in an environment variable folder. We can tell Brownie to always pull from our .env file in a Brownie config.yaml. This is a special file that Brownie always looks for to grab information about where you're going to build, where you're going to deploy, and where you're going to grab things. In this config, all we need to do is add .env and set.env. This is telling Brownie, hey, when you run scripts, grab the environment variables from the .env file. And what we can do is after we import OS, we'll do account equals accounts.add os.getEnv. This is how we get that environment variable private key. Then let's just print out that account and see if we did it right. Brownie, run scripts, deploy.py, and great. All right, great. So this seems to work perfectly, but I like to make this method even more explicit. So we're going to take this version that we just learned and improve it. In our Brownie config, we can actually add more information about what wallets we want to use and when we want to use them. What we can do is we can add a wallets section and add in here a from key section, and then add that environment variable, private key. In your YAML file, if you surround a string with $sign and some curly brackets, it will automatically get transformed into the environment variable. So if we go back to deploy, we can actually change this. We can grab right from our config file. So we'll do from Brownie import accounts, config, and instead of using OS, we can do accounts.add config, and then we'll do wallets, since that's what we're defining right here, and then from key, wallets, from key. And this will do the exact same thing as our os.getEnv. The reason that this is better is because now we have one canonical place where we're always going to pull our private key from, instead of having to go through all of our scripts and update it based on whatever we change an environment variable. Now let's try this out. Brownie, run, scripts, deploy. And great, we see our address printed here. For now, let's just stick with using accounts 0, since we want to just use the account that Brownie makes for us with Ganache. Now, Brownie is really intelligent, and we can actually go ahead and import a contract directly into our script. In a web3.py version, we opened a contract and read from it, and that's how we were able to interact with it after we deployed it. In Brownie, what we can do is from Brownie, import, and then just the name of the contract, simple storage. Then we can do simple storage.deploy, and this is how we're going to deploy it to a chain. Anytime you deploy to a chain or you make a transaction, you always need to do a from, and then say who you're going to be deploying from. What's the account that's going to be deploying this? As you can see, this step of just deploying is much quicker than what we did in web3.py. In web3.py, we had to get the bytecode and the ABI, then we had to get the nonce, we had to create the contract, we had to create the transaction, sign the transaction, and then send the transaction. Remember how I said before, you could either make a transaction or a call? Brownie is smart enough to know whether or not what you're doing is going to be a transaction or a call. In this case, since we're deploying a smart contract, Brownie's smart enough to know that, we want to make a state change, so let's make a state change. It'll return a contract object. So we can just add print simple storage, and we'll see what prints. So let's run this. Brownie run scripts deploy.py. Awesome. So what happened was Brownie, again, per usual, it launched a local Ganache chain, and then it sent a transaction to deploy simple storage. And it says simple storage deployed at, and then the address it was deployed at. And we can see how much quicker this is to actually deploy. Now let's go ahead and do exactly what we did with web3.py. Let's call this initial retrieve function, and then we'll update it with a new value of 15. But we'll do it in Brownie now. Remember, here's how we did it back in web3.py. In Brownie, what we're going to do is first, we're going to do stored value equals simple storage dot retrieve. Now, since this is a view function, we don't have to add from account in here. Again, Brownie is intelligent enough to know if this is a call or a transaction. And we know that retrieve is a view function, so we know we don't actually have to make a transaction here. Then we can print out the value of stored value. Print stored value. Let's go ahead and try this. Great, we get 0 right here. Perfect. Now let's try updating this. So we can do transaction equals simple storage dot store. And in here, we'd want to do 15. But remember, since we're doing a transaction, in Brownie, we always have to add who we're going to transact from. In this case, we're going to do from account. Similar to web3.py, we can do transaction.wait for how many blocks we want to wait. And then let's call that retrieve function again to see if it's been updated. So we can do updated stored value equals simple storage dot retrieve. And then we can print the updated stored value. And if we run this, we now see we have two transactions here. One that deployed our original simple storage contract, and we called the retrieve function and we returned 0 here. Then we updated with our store function, and then we call retrieve again, and we see we did indeed update it to 15. You see how much smaller and easier and more intuitive this is in Brownie, and how much our lives are going to be much better. Awesome. Now you've learned how to deploy to a local chain. Now running these scripts is fantastic, but we need a way to actually automate that our contracts are doing what we want them to do. We don't want to always have to manually check that all of our stuff is doing what we want it to do, right? We don't want to have to manually check that 15 is actually updating appropriately. This is why running tests are so important, and automating your tests is going to be crucial to becoming a successful smart contract developer. Now, I do want to point out that you actually can write tests directly in Solidity. And this is a great way to actually test your smart contracts, is to learn how to do it right in Solidity. However, a lot of the professional developers code their tests in the smart contract development framework language, like Python or JavaScript. Doing it in this way allows you to get a lot more flexibility and customization with what you're doing with your smart contracts, and not being confined to whatever only Solidity has. So let's go ahead and learn how to actually write our smart contract tests in Python. This is what this test folder is for. So we're going to create a new file called test simple storage.py. Make sure you do add test to the front of these, because this is the syntax that PyTest is going to be looking for. And then in our test, we can actually set it up the exact same way we set up our deploy function. We can do from Brownie import simple storage and accounts. Then we can start defining our tests. We want to test to see that when we deploy our smart contract, that it gets started off with 0 in that retrieve function. So we'll create our first test. We'll do def test deploy. And typically, testing in smart contracts, or testing really in anything, is going to be separated into 3 categories: arranging, acting, and asserting. We're going to bounce around and be a little bit loose with this definition for the duration of our tutorials here. However, keep in mind that typically this is the setup that you want to use. Later on, in one of our later smart contract examples, we're going to go through a much better testing setup. So in our arrange stage, we're going to set up all the pieces that we need to get set up. So first, we're going to grab an account. We're going to say accounts equals account 0. And this is really all we need to do to start getting set up. Now, for our acting stage, we're going to deploy a simple storage contract, exactly as we did with deploy. So we're going to do simple storage equals simple storage dot deploy from account. Then we're going to get our starting value. Starting value is going to be equal to simple storage dot retrieve. And we're expecting this to be 0. So then all we have to do in our assert stage is we have to run assert starting value equals expected. So let's recap this. In our arrange stage, we're just getting our account so that we can actually make contracts. Then in our act stage, we're going to deploy this simple storage smart contract. We're going to call the retrieve function to see what its starting value is. And we're going to compare to see if that starting value is what we expect. And we expect it to be 0. We can then test this with Brownie test. And per usual, Brownie is going to kick off a Ganache CLI, and then it's going to test this. For every test you have, you're going to get a little green dot. And we're going to say 1 pass in 1.86 seconds, which is perfect. If we had expected to be 15 and we ran Brownie test, we should get a fail here. Awesome, and that's exactly what we got. Now let's go ahead and test updating this with 15 and see if it works as we want it to. So we can do a new test in here. We'll do def test update storage. And we'll do those 3 phases: arrange, act, and assert. In our arrange, all we need to do is get our account. from account 0. And in this one, arranging is also going to be deploying our smart contract. Since this is really just part of the setup and not the act that we're really testing. Now in our act, we're going to add expected to be equal to 15, and we're going to run simple storage.store expected and then from account. You'll notice this is nearly exactly the same as this deploy function here. Now, same as last time, all we have to do is assert expected equals simple storage dot retrieve. We're saying we want to store 15 in our smart contract, and then when we call our retrieve function, it is stored correctly. So let's go ahead and run Brownie test. Awesome, we can see 2 dots here. This means 2 have actually passed correctly. That's great. Now, I do want to quickly show you a couple of useful tips that I pretty much always do when I'm running my tests. If you want to test just one function, you can do -k. Brownie test -k, test updating storage, and we will only test this test updating storage. We can run Brownie test --pdb and add something wrong in here, like 5 equals simple storage.retrieve. And what will happen is once this kicks out and is wrong, we'll actually get put into a Python shell. And now we can check to see some variables in here. Like if I see what expected is 15. If I try to run simple storage.retrieve, expected is 15. If I run simple storage, I'll see this is the simple storage contract. PDB is a really useful way to mess around and see, okay, well, what did I really go wrong? Why is my test failing? Another important flag is going to be -s. So you'll notice that no print lines actually get sent out when you're working with these tests. If you do -s, it'll be a little bit more robust in telling you exactly what's going on. And if we had any print lines, it would print the lines out as well. Everything that you can do with Brownie test actually comes directly from PyTest. So if there's some flag you want to use or some awesome debugger you want to use, you can use it with Brownie just by looking at the PyTest documentation. All the tools are exactly the same. All right, we're coming along fantastically. We have a script to deploy. We have some tests. We have our contract. This is great, but now we actually want to deploy to a testnet. How are we going to do this? Let's look at back how we did it with web3.py. Back in web3.py, to deploy this to a testnet, we just needed to add our HTTP web3 provider, which was our Infura account, and that was pretty much it, and add our address and our private key. In Brownie, our lives are even easier. Brownie comes prepackaged with a list of networks that it's already compatible with. You can see all of the networks by running Brownie networks list. Now, mine has a couple more actually because I've been playing around with this for a long time. But if you want to see all the different networks, you can look at this list here. Something important to note is that there's a difference between the development networks and the Ethereum networks. Whenever we deploy to a network, we default to this development network. Any network that you see under this development section is going to be a network that is temporary. These are networks such as the temporary ganache network that Brownie automatically spins up when we run any of the scripts we've written so far. So this is really important to note. Remember, anything in this development section is going to get torn down after it's deployed. However, the Ethereum ones are going to be our persistent networks. Anything under this Ethereum tab, Brownie is actually going to keep track of our deployments and keep track of everything in there. These networks under here represent persistent networks like mainnet, RinkB, Coven, etc. Now in our web3.py, we used an RPC URL or an HTTP provider from Infura to connect to a testnet. We're going to use that exact same methodology here. So how do we actually get this RPC URL, this blockchain URL into our Brownie smart contract package? Well, one of the easiest ways is with an environment variable. So Brownie actually already knows that Infura is the thing and can look natively right away for Infura. Web3 Infura project ID and use our project ID from Infura. If we go to our project back in Infura and we go to settings, you'll see the project ID is a little bit different than the whole URL. It's just going to be this ID right here. We can then copy this and paste this right into our .env. Now that we have our Web3 Infura project ID directly in our project, if we do Brownie networks list, any network that Infura has access to, you'll see a little Infura in colons here. These are networks that Brownie will automatically know about if we're working with Infura. So we can see here that RinkB is one of these Infura keys. If we wanted to deploy to RinkB, we could then just run Brownie run scripts deploy.py and then select the network with -- network RinkB. Now we're going to get an issue here because remember, account 0 only works when Brownie works with a Ganache CLI. We have to use our actual private key here. And that's where some of those other versions of working with private keys is going to come into play. Sometimes I'll even add a get account function. So down here, we'll do def get account. And then in here, I'll just natively check. If we're working on a development chain, we'll use account 0. And if not, we'll use the method that pulls from our config. So we can check by saying if network.showActive equals development, then return accounts 0. Network is another keyword that Brownie actually has. This network keyword allows us to interact with different networks. Now, if it's not on the development network, we're going to pull directly from our config. So we'll return accounts.add config wallets from key. And instead of doing account equals account 0, we can just do account equals get account. Now if we run Brownie run scripts deploy.py network RinkB, it should pull directly from our config file. And great, we can actually see transactions being sent directly on the RinkB chain. If we pull up Etherscan, the RinkB Etherscan, and we take this transaction hash and post it into the RinkB Etherscan, we can see this transaction actually going through. We've deployed our simple storage contract and it's initialized to 0. Then we're going to go ahead and update it, and it gets updated to 15. Now, once we've deployed to a blockchain, you'll see our build contract will actually change. Our deployments folder will have a new deployment. Every time you deploy to a blockchain, Brownie will actually save that deployment so you can always go back and say, where did I deploy that, or what happened with that deployment? You'll notice that it's separated by chain ID. Remember, the chain ID of RinkB is 4. You'll also notice that none of our development deployments are in here. Again, anything that's in this development section isn't going to get saved to the deployments area. However, anything up here in these ones will get saved. And that's going to be really powerful because we can actually interact with contracts we've already deployed onto a chain. So let's go ahead and even add a new file in here called read value. This function is going to read directly from the RinkB blockchain, and it's going to read from a contract that we've already deployed. Remember, we did something similar in web3.py by using the address and the ABI. We're going to do the exact same thing, but in Brownie. So in Brownie, again, we're going to do from Brownie, import, simple storage, accounts, and config. We'll do def, read contract, and we'll just do pass for now. And then we'll do def main is going to be read contract. Whoops, didn't mean to do that down here. And if we run, Brownie run scripts, read value.py, network RinkB, obviously right now, nothing's going to happen. So how do we actually interact with this simple storage contract that we've already deployed? Well, this simple storage object is actually just an array. If we were to print simple storage, let's see what we get. See, we get this brownie.network.contract.contract container object at here. This object works the same as an array, and we can access the different indexes inside of it. So what if we do print simple storage at position 0? You'll see we get this address here. And if we check on Etherscan, we can see that this is indeed the contract that we just deployed. Brownie knows that we just deployed it because, again, in our build section in the deployments on the Rinkeby chain, which has the chain ID of 4, we have this contract that we've deployed. Now we can actually just directly interact with this contract. We can do simple storage equals simple storage of 0. Or if you're always looking to get the most recent deployment, -1 is a little bit easier. If we always do 0, we're just going to get the first deployment that we made. And if we make deployments later, we're never going to get past it. I want to always work with the most recent deployment, so I can just do -1. Remember how I said, whenever we work with a smart contract, we need to know its ABI and its address. Well, Brownie already knows what the address of this contract is. It's got it saved in this deployments folder. It also knows what the ABI is, because when we compile it, we get this big JSON file, and one of the first inputs that it has is the ABI. So Brownie automatically knows what the ABI is and what the address is already. So then we can just go ahead and run simple storage .retrieve and print it out. And we should see 15 since we already updated it. Brownie runs scripts, read value to pi -- network Rinkeby. And great, we do indeed see 15. Now that we know how to write some scripts and actually deploy things with Brownie and work with Brownie, I'm going to show you one of the most powerful features to also work with Brownie. Typically, we write our scripts when we want something to be reproducible and we want to do something over and over again. Deploying a simple storage or reading a value is something that we're probably going to want to do over and over again. However, maybe we want to work with some of these contracts a little bit ad hoc and get into a shell where we can actually interact with these contracts. This is where the Brownie console is actually going to come into play and make our lives a lot easier. So what we can do is we're going to Brownie console, and what will happen is Brownie will actually kick us off into a console. It has all of our contracts and everything already imported. So if I run simple storage, it gives me back an array. It's saying, great, that's your simple storage contract. Since we're working on a brand new local test environment, there are no simple storage contracts deployed. So what I can do is I can say account equals account 0. And we now have our account that we can work with. Accounts is one of these keywords that's automatically imported into our Brownie console. Everything that is imported via Brownie in our script is automatically already imported into this little shell here. So with that being said, we can go ahead and even deploy our simple storage contract. So we can literally take this line, copy it, paste it in here, and you'll see exactly the same thing that happens as if we ran our script. We get a little transaction hash here, and we get a simple storage. Now, if I type simple storage, the simple storage variable now has a storage contract here. If I type simple storage, you'll see I now have a contract in here. The length of simple storage is now 1 because I've deployed one simple storage contract. If I were to deploy it again, the length is now 2. Brownie now knows I'm holding on to 2 simple storage contracts, and I've deployed 2 simple storage contracts. I can then even do things like simple storage .retrieve. And we can see we start with 0. I can go ahead and even run simple storage .store 15 from account. And we'll see we'll get a transaction. Now if I rerun simple storage.retrieve, a nice little hack here is in these shells, if you just hit the up key, you'll actually be able to go back in the history of the shell. So if I just hit up twice here, I can go back to this command and I hit enter. Now we see the 15 is here. So the Brownie console is a great way to interact with these scripts in a more ad hoc manner. Maybe we want to test some weird functionality, or maybe we have some experiment that we want to try. It's a great way to really interact with anything that we have in Brownie. And the other thing is we can do everything that we normally do in Python in here. So for example, I could write print hello, and it'll print out hello. I could do cat equals 1 plus 2. And I type cat, and I get 3. So this Brownie shell is a Python shell with all of our smart contract features already natively integrated, and it's incredibly powerful here. We can go ahead and quit it by doing quit. So I know we've learned a lot so far. I'm sure you're starting to see why working with Brownie is so much easier and makes our lives as smart contract developers a lot easier for testing them, deploying them, and working with them. All right, let's move on to our next project. Is we're going to take the FundMe contract that we made recently in Remix and actually import that one into Brownie. With this, we're going to go over a lot more of the advanced features that Brownie has to offer us. And we're going to get into some more sophisticated testing and deployment mechanisms for this. So I'm going to make a new directory, Brownie, FundMe. We're going to cd into Brownie FundMe. And remember, if you hit tab, it'll autocomplete. And we're going to open this up in a folder. Again, if code period doesn't work, you can always go up to File, Open Folder, and do it like that. We're in our Brownie FundMe project, and we're going to initialize a new project by running Brownie init. And we're going to create a new contract called fundme.sol. And this is going to be exactly what we had before for our FundMe contract. So if you have Remix up, great, you can go ahead and grab it, or you can check the GitHub repository associated with this course and just copy paste the code. Now, typically, this is where in our last project, we just ran Brownie compile. But what happens if we run Brownie compile here? Brownie is going to give us this error. It's going to say, hey, this source wasn't found. So what's going on here? Well, Remix understands that @chainlinks/contracts is an NPM package that it can import from. However, Brownie isn't aware of NPM packages, and Brownie can't actually download directly from NPM. However, Brownie can download directly from GitHub. So we have to tell Brownie where it should be downloading these third-party packages from so that we can use them in our contracts here. And while I'm in here, I might as well change the global compiler version to 0.6.6. And we'll just change the compiler version to caret 0.6.6 so that our linter is happy. So we need to tell Brownie where to import these contracts from GitHub instead of from NPM. Luckily, there is a package out there specifically created for downloading Chainlink contracts. The way that we can tell Brownie where to get these from is in our Brownie config. So let's create our Brownie config. And in here, we're going to create a dependencies section. And this is where we tell Brownie the organization / repo name at version that we want to download from. So to get these Chainlink contracts, we can look up Chainlink Brownie contracts, and we can use this repository to get it. So instead of downloading from NPM, we're just going to download directly from this GitHub repo. So we need to tell Brownie the organization, which is going to be Smart Contract Kit, the repository name, which is going to be Chainlink Brownie contracts, and then the version. You don't always have to use the latest version here. And in fact, we can go to the past 9 versions by clicking on the version history. We're actually going to be using 1.1.1. And yes, it does look like the latest version went backwards, but as of a recent release, as a 1.2.0 version of this package, all the releases of Chainlink Brownie contracts is going to match exactly the @Chainlink contracts NPM tag. So that's why it looks like this is an earlier version. So we'll say 1.1.1. So great. So now Brownie knows to download this repository from GitHub. Once we do that, everything in this contract section will be available for our Solidity code to import and use. However, that's not the final story here. We also need to tell Brownie what this @Chainlink thing means, because we're downloading from Smart Contract Kit / Chainlink Brownie contracts. Brownie's going, okay, cool. Well, what's this @Chainlink thing? So we need to tell Brownie whenever we're using @Chainlink, we're actually referring to this import. So we need to tell the compiler this. So let's add a new section. We'll say compiler. When it compiles Sulk, we need to remap @Chainlink. We need to say whenever you see @Chainlink here, it means we're referring to this package. So compiler Sulk remappings @Chainlink is equal to this package up here. Now, let's go ahead and try to compile. Perfect. We see here that it compiles successfully. And if we look at our build folder in the contract section, we now have this new folder called dependencies. And if we even expand this a little bit, we can see it says dependencies, smart contract kit, Chainlink Brownie contracts at 1.1.1. And this is what it downloaded from that GitHub repository. It downloaded Aggregator v3 interface and Smart Math Chainlink because we're using both of those files in our Solidity code. All right, great. So let's write our first script to deploy this to a development ganache chain, to Brownie's built-in chain. Let's do this. So in scripts, let's go ahead. We'll create a new file. Let's go ahead and build a simple deploy script to work with Rinkeby, and then we'll actually learn how to deploy this to our own local ganache development chain. So let's build our deploy script. So in scripts, we'll do new file, deploy.py, and we'll start by doing def deploy fundme. Then we'll do pass for now. And then we'll do our entry point of def main, and then we'll call deploy fundme. In this file, of course, we're going to do from Brownie import fundme so we can actually use this. And let's go ahead and build this deploy fundme function. So first, we're going to need to get an account. And same as last time, we used a function called getAccount, which would know to switch back and forth between if we were on development or if we were with an actual testnet that we could pull from our config. We can actually, once again, copy that function and use that in our script here. So once again, we can use that getAccount function that we had before. What I like to do with this getAccount is add it into its own file called helpful scripts. So what I'll do is create a new file called helpful scripts.py. And in here, I'll add that getAccount function, right? So literally just pasted it from our last project. And just a quick recap on what this is doing is we're saying if the network is in development, we're going to use the accounts 0 syntax. Otherwise, we're going to pull from our config. And of course, we're going to have to from Brownie import network, config, and accounts. And then of course, in our Brownie config, we're going to have to add wallets and from key. So let's go to our config. We'll do wallets, from key, and we'll add our private key environment variable setup, which of course means that we're going to have to set .env to .env, and we're going to have to create a new file, .env, and we'll paste the exact same values from our last .env. So it's going to be our private key and our project ID. Kind of just a lot of the basics of the setup here. But now that we've added this getAccount to its own script, how do we actually use that in our deploy script? Depending on the version of Python that you're in, you might actually have to create a new file first named __init__.py. You might not, but just in case, let's make it here because it doesn't hurt. And with this, now Python knows that it can import from other scripts and other packages in this project. So now we can do from scripts.helpful scripts import getAccount. So we're importing that getAccount function from our helpful script here. And we're going to make this getAccount function a little bit more robust a little bit later, but for now, it'll work perfectly for what we're looking to do. Now we can just run our typical deploy function. Do fundme. We'll do the fundme contract equals fundme.deploy. And of course, we'll do from account. Because again, since this deploy is going to make a state change to the blockchain, we always need to do a from account section here. Then we can even do a little print. We'll do a printf here. So we'll say contract deployed to fundme.address. This is how we'll get the address of our fundme. And great, we can even go ahead and try this out right now. Remember you'll need some testnet Rinkeby Ethereum in your MetaMask. Brownie runs scripts, deploy.py, -- network, Rinkeby. And Perfect. Contract deployed. Here it is. We can even go to RinkB Ether, scan again. And we can see the contract right here. Now, this is great and all, but if we look at our contract, it's kind of this blank jarble of bytes here, right? Nobody can actually see this contract and easily interact with it. And we want to make our contracts easy to interact with. What we can do on Etherscan is verify and publish our smart contracts. To verify our smart contract, all we have to do is hit that verify button. We'll choose our Solidity compiler type, which we know is going to be 0.6.6. And we know we're working with the MIT license here. Now, to continue, we would then have to add in all of the rest of these pieces. We'd have to do optimization, which is going to be yes. We'd enter our Solidity contract code below, which importing fundme like this wouldn't actually work because Etherscan doesn't know what @chainlink/contracts is. So we would have to copy paste the code from these imports to the top of our contract here. Removing these imports and copy pasting the code associated with these files is known as flattening. And this is an important concept for verifying our smart contracts on platforms like Etherscan. However, Brownie has a really nice way to get around this actually. What you can do is go to their main site, etherscan.io. You can sign in and sign up and get an API key. I've already signed up, so I'm going to go ahead and sign in here. Log in. And what we can do is we can go to my profile and scroll down to API keys. And this is where we can create an API key for us to interact with and programmatically verify our smart contracts on Etherscan. I've already got one here, but all we need to do is hit add. We'll give it a name. I'll call it verify Brownie. Continue. And we've created this new API token that will allow us to verify our smart contracts. What we'll do to use this in Brownie is we'll copy this API key and we'll move back to our scripts here. We'll set this API key as an environment variable. So we'll do export. The name of this is Etherscan token, and we'll set it equal to that key that we just got. Now, to verify this, all we have to do then is once we deploy this contract, we'll tell Brownie whether or not we want to verify the contract. So after our dictionary here, we'll do comma, publish, source equals true. We're saying, yes, we would like to publish our source code. Now, if we rerun this script, let's see what happens. Again, remember, we'll do Brownie, run, scripts, deployed up high, -- network space rinkeby. And it says fundme has been deployed to here. Now we're going to say waiting for API rinkb.etherscan.io to process contract, and we're submitting our code for verification here. And it'll say verification pending, verification complete, pass verified. And it'll say where the contract has been deployed and what's been done with it. Now, if we go back to Etherscan, again, we're going to have to go back to RinkB Etherscan, because we deployed this to RinkB, and we paste this in. We now have this little check mark associated with our contract. And if we click contract, we can see all of the code in here for our contract. We have contract fundme, payable, you need to get more ETH, everything that we defined in here. And if we scroll up, we can see that they did indeed flatten this contract, right? They pasted that aggregator v3 interface import, and they also pasted that library safe math chainlink. Now that's verified, we can even read the contract, see the different public variables in here, such as the owner, get version, get price, and all the exact same buttons that we saw in Remix. This read contract section is for all these view functions, right? The ones that aren't going to be making a state change. Write contract is going to be for when we want to call something like fund or withdraw. And we could even go ahead and interact with this. So for example, we could connect to Web3, MetaMask, okay, and it would automatically get connected to our MetaMask here. Then we could call fund and withdraw just like we did in Remix. If you want to give it a shot, go for it. All right, we're back in our code editor after successfully verifying one of our smart contracts on Etherscan. Now, just a quick note, sometimes the verification process can be a little bit touchy. And for version of Solidity 0.8.4, There's currently a bug that makes verifying a little bit tricky, but it's being worked on, so don't be discouraged if it gets a little bit funky. So this is great that we've written a deploy script for deploying directly to Rinkeby. However, as you know, we're always going to want to be able to deploy to our own local blockchains or Brownie's built-in development chain so we can test a lot quicker. And so that we can write some tests. But we have a little bit of an issue here. The first issue being that our FundMe contract currently has an address hard-coded to work with the Rinkeby chain. So in fact, the way it's written right now, it's going to be hard to work with any other chain other than Rinkeby. The second bit is that these price feed contracts don't exist on a local Ganache chain or a Ganache chain that Brownie spins up. There's two ways we can get around this. We can do what's called forking and work on a forked simulated chain, or we can deploy a mock or deploy a fake price feed contract on our Ganache local development chain. Deploying mocks is a common design pattern used across all software engineering industries. And what it applies doing is deploying a fake version of something and interacting with it as if it's real. So again, right now, if I run Brownie, run scripts, deploy.py, and I don't set this network flag, we're going to actually have a default spinning up a Ganache chain, and it's even going to try to verify it, which it's going to run into an issue because we can't verify on a Ganache chain. So we have a couple issues that we need to address here in order for us to get this to work on a Ganache chain. Similar to how in this get account function in our helpful scripts, we do a little bit checking. We say, hey, if we're on a development network, use this development accounts version. Otherwise, pull from our config. We can do that exact same mentality, but with working with these mocks. So the first thing that we need to do is we need to parameterize our FundMe Solidity smart contract so that we don't have this hard-coded in here anymore. So what we can do is right when we deploy this contract, we'll tell it what price feed address it should use, right when we call our deploy function here, instead of having it hard-coded. And we can add this parameter to our constructor. We'll say address price feed as an input parameter, and whatever input parameter we use here is going to be our global price feed address. So instead of us creating these aggregator v3 interface contracts right in the functions here, we're just going to create a global one. So we'll say aggregator v3 interface public price feed, and right in our constructor, right when we create this, we'll set price feed equals aggregator v3 interface price feed. And now what we can do is we can just delete this part, because as you can see, this is doing the exact same thing as up here. This is doing aggregator v3 interface price feed equals aggregator v3 interface, and then the address here. And we're going to do the exact same thing, but in our constructor, meaning right when we deploy this contract. So we can delete this, and we can delete it here as well in our getPrice function. We can even verify this with Brownie compile. And great, looks like it's compiling perfectly. Now, our deploy function is going to need to look a little bit different. We're going to need to pass the price feed address